Pepe's work is at the edge of the edge. I mean, he's always trying to push the limits. It spans from science, engineering, art, to philosophy and getting into ethics questions and understanding how all of these things intertwine in the greater field and how we can actually implement our discoveries in the world.
I know Pepe for about 3-4 years. He is definitely one of the best researchers in brain-computer interface.
My laboratory focuses on reverse engineering the brain and developing neural interfaces so that the brain can communicate directly with external devices like robots or exoskeletons or prosthetic devices. What you're looking today here is a NSF-funded project to look at the next generation of prosthetic legs that are controlled with myoelectric, muscle, and brain activity.
I started to, looking for a collaborator, and I actually come across Pepe, and then we discussed the ideas, and then we put a proposal together. So now we have funded, and then we are really working on this together. So I am very excited.
Starting from the beginning, we'll be trying to really figure out what's going on in the brain during movement over complex terrains like stairs, ramps, transitions from flat ground to stairs, etc.
So we are trying to harness the intent signals from the brain, which happen early on, and combine them with the intention that you can detect at the muscle. The idea is that when you practice enough with the artificial leg, the brain assimilates that leg in a way that it becomes part of itself, right? So you have the brain has developed a model of the prosthetic leg that can use to predict and to know what to do with its leg. Right? Our group is also working on upper limb prosthetics. Back in 2011, we started a project to develop a brain-machine interface for the control of an artificial hand. We have been able to demonstrate the feasibility of doing that by recording brain activity from the outside using electroencephalography or EEG.
Electroencephalography or EEG is just measuring the changes in electrical activity in the brain.
We developed an algorithm that basically listens to the brain and detects the intent and then sends that intention to the prosthetic hand so they can perform for the amputee. And we expect by the end of next year to have a full system that includes not only the control of the hand by the brain, but also provide other type of feedback to the user coming from the artificial hand. Because when we grasp, we use not only visual feedback, we see what we do with our hand, but we also feel what the fingers are doing to the object. So the whole body we are looking at. And we have another NIH project that is looking at how the brain develops social cognition. So we are looking at the first signature, the first time that these babies are interacting with a purpose with us. So every brain is very unique, right? And it's genetics, is environment, is our parents, our friends, everybody's different. And I think that art provides a window to study that because we are unique in how we respond to art. And the new project from the National Science Foundation, which just started this September, to capture massive amounts of data from people like us at public settings. The setting here is going to be museums. Really, the work is the work of my students. There are about 30 people in the lab. I'm the conductor, but my students are the players, right? And we practice a lot.
I think in a lot of cases, these projects could be very sort of singular, where we have artists and all they do is focus on artwork, and then we have engineers and all they're focusing on is engineering. It's not the case in our lab. I think the underlying focus is really on understanding how the brain is involved in all of these processes. But if you don't understand the creative process, but you understand, let's say, the movement it's going to be challenging to intertwine them into someone's daily life.
I would say, in general, impression he's an excellent researcher, a great colleague, and also is my friend.
I think we can harness the brain to gain additional channels for communication, and we have. And that's particularly important when you have a disability, that you can use that channel of communication. Right? When I was finishing my undergrad back in Monterrey Tech, in Mexico, my mom went into a coma and for a year. And I was studying engineering, and I didn't understand why we couldn't communicate with her. Doctors couldn't tell me. So I started to read and decided to to go to graduate school to study neuroscience so that I could at least understand that. So it has been a long journey for me. I don't know if I'm not succeed on any of these projects, right? But you don't risk, you don't discover.